Testing, testing, 1, 2, 3. Can y'all hear me? Hello?
Yes, ma'am.
Awesome sauce. Sorry, I'm a little late. My last class went over. I'm just going over in all my classes today. Okay. So we are on the last section, right? We finished. I think we finished. Yeah, we finished example. Yeah, we did that. Okay. So we're on page 139.
Yes, ma'am.
Okay. All right, here we go. Last class, everybody. We made it. So we only have one more section to do, and it's I don't know. I'm gonna add a lot of notes, so just be prepared to take some notes today. Let's see. So we're gonna just spend some time on this very first page. So what we're gonna do now is we are going to do polar equations of conics. So far, everything that we've been doing has been conics in rectangular form using x and y's, and we've had that format. We learned about polar equations where we were graphing. Remember, we were graphing the roses and the lemon skates. Remember that? We had that fun class when we were doing that in Desmos and things of that nature. Well, we can actually graph conics in polar form. So before we do that, let's recall that polar coordinates have the points r comma theta. Y'all remember that? So your r is a function of theta, right? So r equals a function of theta. So that's what you should have on the recall. Right? We talked about eccentricity, and with eccentricity, if you're dealing with an ellipse, it tells you the ovalness of your ellipse. Okay? But it can also, in polar form, help you find what the other types of equations are. So if you go down to number one says a parabola. I don't want to write the whole thing. So let's write parabola. You have a parabola of e equals 1, okay? And I want to write down that the axis of symmetry is perpendicular to the directrix. For number 2, you have an ellipse. Your eccentricity would have to be between 0 and 1. And your major axis is perpendicular to the directrix. Number 3, we have a hyperbola. Your eccentricity is greater than 1. Your transverse axis is perpendicular to the directrix. So those are good notes to have. So as you're writing this down, if you're writing this down, the polar equations of the conics are located in the middle of the page. R equals ED over 1 plus or minus E cosine or sine of theta. I'm going to talk a little bit more about that here in a second. I'm actually going to split them up. But if you go back to what we did in rectangular form, only the parabola had a directrix, right? But now in polar form, they all do. Okay. So they're all going to have, I don't even know, directrixes, directri, I don't know, more than one directrix. And something else that's special. So all of them are going to have a directrix now. And what they do in polar form is they put a focus. They make sure that one of the foci, because remember, ellipses have more than one, hyperbolas have more than one foci. A parabola only has one. But what it does is it puts the focus on the origin. So either one of the foci for an ellipse and a hyperbola is going to be on the origin, or in a parabola, the foci will be on the origin. Now remember, we didn't call it the origin when we were in polar form. Does anybody remember what we called the origin when we were in polar form?
No, I think it was it 0?
Mm-hmm. That's where it was, but it had a special name. It was called the pole.
Oh yeah.
The pole. Remember the pole? We did stuff that was symmetric about the pole, about the line pi over 2, theta equals pi over 2. So that was a couple of sections ago, but we're going to put a focus on the pole. So if you read the bottom, it says D represents the distance from the pole to the directrix. And there is always a focus at the pole. Is that okay? So the sentence that's under that is D represents the distance from the pole to the directrix. And there's always a focus at the pole. Okay. Now, at the bottom of page 11.6, the bottom of page 139, I want you to draw 4 pictures. So you're going to have 4 graphs. Okay. So here's the focus. Okay, let's say that's the focus. And you have your directrix over here. Okay, so this would be x equals d for your directrix, right? Which means that you have this picture going this way. Okay. Then the formula is R equals ED over 1 plus E cosine theta. This is the formula for that picture. Now, the reason why I did little dotted lines is because what this is, you guys, these are the parts of the conic that are closer to the focus and this directrix. So this could be an ellipse. If you kept drawing it, it could be a parabola. It could be half of a hyperbola. Make sense? I'm only drawing the part that is closest to this particular foci and this directrix. But we don't know where the rest of the picture is. It'll make more sense when we do it here in a little bit. We just want to make sure that we have this note. Okay? The next one is, what if we have the focus? Of course, we're always going to have a focus at the origin. But your directrix is on this side. So this will be x equals negative d. Right? And if I were to draw the picture closest to here, it would look like this, but I don't really know what's going on past that, because I can make this an ellipse, I can make this a parabola. And this formula would be R equals ED over 1 minus E cosine theta. Here's a focus. Let's say your directrix was up here. That'd be y equals d. And those would be my pictures. Are we okay with that?
Yes, ma'am.
Any questions so far?
Not yet.
Okay. Moving right along, let's go to the first one. So we're going to look at the example. Make sure you have that. It's a very important note. I refer to those pictures a lot. That's why I wanted to draw them. The first example says, write a polar equation of a conic that has its focus at the origin and satisfies the given conditions. So all it says is that we're going to have a hyperbola. This is part A. So we're going to have a hyperbola. The eccentricity is going to be 4/3. Your directrix is going to be at x equals -3. Is everybody okay with that? Everybody see where I am? So if I were to come over here and sketch this bad boy, you have a focus at the origin. You're always going to have a focus at the pole. Okay, so we have a focus at the pole. Your directrix is x equals -3. So -3 would be 1, 2, 3. Here, pretend that went through. Pretend that went through. Let me delete that. Let me delete that line. Okay, that's -3. There you go. X equals -3 is here. Do you agree with that? So, do you see what picture this is matching up to be? Do you see what I mean?
The second one? 1 minus e cosine?
Oh, here we go. Yeah, the second one. Does that make sense? And so if I were to come over here and start trying to write this formula in, I would have R equals, they told us what our eccentricity was, 4/3. D is always the distance between your directrix and your focus. That is located on page 139 in the note. D represents the distance from the pole to the directrix, right? And you have your pole is a focus. So that distance is 3. Is that okay with everybody? So this is going to be 3. Oh, Dr. Crucieli, isn't it -3? Not, it's distance. It's not the value itself. We're going to take care of the negative with the fact that there's a negative right there.
Okay, so it'll just always be a real real number.
Yes. You're going to take care of with direction with a negative or positive on the bottom. So when you put in your D, it's just distance, not direction. Okay. And then on the bottom, you're going to have 1 minus 4/3 cosine theta. Then what we're going to do is we're going to make this look pretty because this is not pretty. Okay. And so when we do that, we're going to have 1 minus 4/3 cosine theta. So I went ahead and multiplied 4/3 times 3. And then they don't even like fractions anywhere in here. The only fraction you can have is the one that you have the ED on top and the 1 minus. So what I'm going to do here is I'm going to multiply every single term by 3. And when I take this and I multiply every single term by 3, I get 12 divided by 3 minus 4 cosine theta. No fractions besides the main one, which is what it likes. And this right here is your final answer. This is the equation for the hyperbola that matches those conditions. Are we okay with that? Is there any questions or where I got anything?
No, ma'am.
Okay. Then part, oh, I need a new paper. Okay. So part B. Part B says, what does part B say? You have a parabola. And you have a vertex at 5 comma pi halves. Okay, that's all it says. I want you to sketch a picture of what this looks like, and then we're going to talk. So what do you think that looks like? Y'all remember? Do you remember how to graph polar points? I hope. So I want you to recall that part. Start thinking about what this means. Okay. Hopefully you have some ideas down. So if I were to draw this picture, that means that you have a focus at the pole, right? And then 5 pi halves. Wouldn't 5 pi halves be here? 5 pi halves, right? So then it's going this way since it's a parabola. And remember, if the distance between your vertex and your focus is 5, then what is the distance between your focus and your directrix? Right? Also 5. So this is y equals 10. Are there any questions? Yes, no, maybe? Remember, this is not rectangular. You're not coming over here to 5. Oh, I went 1, 2, 3, 4, 5 pi halves. That's rectangular. This is polar. This is 0, pi halves, pi, 3 pi over 2. Remember that? So if it's 5 pi halves, that just means you have a radius of 5 and you went a pi halves distance up. Or you went to the pi halves. You went 5 units up on the pi halves axis. So this is the picture you would have. So what is your eccentricity? What is D? Hello? Yes, thanks, Jude. Eccentricity is 1. And what is D? I read it to you twice. What is D?
The distance from the pole.
From the pole to the?
Directrix.
And how far is that?
10.
10. It's 10 units. It's the distance from the pole to the directrix. So that's 10. Okay. And then what picture does this look like? Let me go back down here. Oh, I have more paper.
The third one? 1 plus E sine.
Yep. Okay. So let's go back up to the top. So we have the third picture. So do you agree we're going to have, oh gosh, I don't know what's going on. Hold on. Something happened. Oh no. What is happening to my computer? Go ahead and you write it. What's happening? I must have pushed something. Okay. So what do you get?
10 over 1 plus sine theta.
10 over 1 plus sine theta. Looks good to me. Good job. Any questions? I don't know what happened to my picture. Something happened to my computer and it just like freaked out. We okay with that?
Yeah, I think so. That one was pretty easy.
Okay, so let's look at the next one. The next one's a little bit more complicated. We're going to go nice and slow, okay? So part C says, what does part C say? So we have an ellipse, okay? The eccentricity is 0.4, and we have a vertex at 2, 0. So if I were to draw what they gave me, I know that I have a focus here, and then at 1, 2, 0, I'm going to have a vertex. Do we all agree with that? Everybody good? Which means if that's my focus and that's my vertex, that means my directrix is over here somewhere. Do we agree with that? And if it's an ellipse, it looks like that. That's just a sketch. What is going? No, don't do this again. Okay. I think my thing is just hitting this button. Okay. So do we agree that the picture represents the formula R equals ED over 1 plus E cosine theta? Is everybody okay with how I got that?
Yes, ma'am.
Okay. We also know that E is 0.4, right? 1 plus 0.4 cosine theta. We do not know what D is. Okay, we don't know what D is. Oh, I forgot to even put D. So they gave us a point that was on the ellipse. The point on the ellipse is 2, 0. This is R, this is theta. So I can put R is 2. I have no idea what D is. And then cosine of theta is, or cosine of 0, if I'm showing all my steps, cosine of 0, which gives me 2 equals 0.4 D. And on bottom, we have 1 plus 0.4 because cosine of 0 is 1. And then this becomes an algebra problem. Can't you solve for D?
Yes, you can.
Okay, so somebody do it to tell me what D is. Yeah, I got that too, Jude. Thank you. So D is 7. Is everybody okay with that? D is 7. So then you get R equals, I'm going back to here, R equals, E is 0.4. What is 0.4 as a fraction? Someone change that into a fraction for me. 2/5? That's still not pretty. So what is our final answer going to be? And is there any questions on where I got anything? No, yes, maybe? We okay? Y'all are so quiet. Why are y'all so quiet?
I'm trying to catch up. Sorry. I try to do it by myself without listening to you at first, and then I kind of fact check myself off of your work.
Okay. Did you get everything okay?
Yeah, no, I'm right so far.
I mean, how quiet y'all are. Like I'm okay. I'm just gonna act like I know nothing. Watch this. Let me ask. These are some questions I would have asked if I were sitting where you're sitting, but nobody's asking me, so I'm thinking everybody's understanding. Here's the first question, Dr. Crucili. What if this is 2? The distance between the foci and this dot right here is 2. Then how come that's not 2? Because that's what happened over here when we did the parabola. When we did the parabola, our vertex was at 5 pi halves. It was at 5 pi halves. So here's 5 pi halves. This is the pi halves line. Here's the focus. This was 5. So how come, and you went, this is 5, and so you said you were at y equals 10. Y'all remember that? So everybody understands why that's not 2. Nobody asked. I'm over here thinking we understand. You have to ask questions. Nobody asked me that. So I'm thinking you understand. I was waiting for someone to say, oh yeah, we already know the directrix should be 4 because it should be 4 away from the focus. And I would have came in and said that this equal distant thing only happens with parabolas. So the whole equal distance between the foci and the vertex and the directrix, the fact that they're equal, only happens with parabolas. You knew that from when we did parabolas with rectangular, but we never did directrixes with ellipses or hyperbolas. So they're not equal. Okay, so you cannot assume with ellipses and hyperbolas that the distance between the foci and the vertex and the directrix is the same, because it's not. This is 7, not 2. This distance is 7, not 2. Okay, so please step up, ask a question. So now that we know that, we didn't know what D was. We knew what the eccentricity was because they told us. If you change this into a fraction, you get 2/5. So I put 2/5 in for E, and they give you a point. Tip 80% of the time when they give you a point, it's because you have to plug it in, right? So they gave us 2/5 as E. They didn't tell us what D was. We can't assume that D is equal to 2. So I had to come over here and substitute 2 and 0 in to solve for D. And that's how I got that D was 7. Then I can put the 7 in for D, we already know the eccentricity is 2/5. We got that it's the 1 plus E cosine theta from the picture. So I'm okay with that. But remember, it doesn't like fractions. So I'm just going to go ahead and multiply everything by 5. If you multiply everything by 5, you get 14, 5 plus 2 cosine theta. And that is the answer. Okay.
Yep.
Okay. Yep.
That's what I got. So there's nothing else to say, I guess. Like it makes
sense. So just make sure
sense why it wasn't 2, because I just automatically thought, since we didn't do that earlier, it's just kind of
so there's
equal.
a reason why. Yeah. So the only time that it's equidistant is when you have a parabola, which we learned about the equidistant characteristic when we did parabolas back in, I don't remember what section it was. This is the first time that we've ever dealt with directrixes with ellipses and hyperbolas. So I just wanted you to know that that's not a consistent rule, that the directrix has to be equidistant. That only happens with parabolas, not ellipses and hyperbolas. Okay. Okay. So now we're on example 2. In example 2, I'll do the first one with you. Okay. On example 2, they want us to identify the conic, analyze the conic, and then sketch it. Okay. So A says R equals 3 over 2 plus 2, right? Sine of theta. Okay. So what they did is they were going backwards now, right? Before we had these characteristics and we came up with the equation of the conic. And now, now we have the equation of the conic. And I want to know some characteristics. The key thing here, you guys, is that this number, if you go back and look at the formulas, the very important pictures that I gave you, this first leading number is a 1. So the first thing that I'm going to do is I'm going to divide every single thing by 2, because then that'll give me a 1 here. So now I have R equals 3/2 over 1 plus 1 sine of theta. If you notice, going back to the very important formula in pictures, the number in front of sine, cosine is your eccentricity. So I know that my eccentricity is 1. So just one more time, just to format this correctly, I'm going to have 1 times 3/2. Here's your E, here's your D, over 1 plus 1 again. There's your E, sine of theta. So by getting it formatted like how it is on the formula, we just found out that E is 1 and D is 3/2. Is everybody okay with that?
Yes, ma'am.
So what kind of conic is this? Jude, I think Jude's coming in. Yep, thank you, Jude. It's a parabola. You know it's a parabola because your eccentricity is 1. That's why these notes in the very beginning are very important. Your eccentricity is 1, so this is a parabola. If you go back to the very important pictures, if you have 1 plus E sine theta, if you have 1 plus E sine theta in your denominator, then that means that your directrix is located here. Do we agree with that? And remember, your directrix is the distance
from the pole to the directrix.
Yeah. So this is y equals 3/2. Are we okay with that?
Yes.
So if I were to sketch this already, I would have this lovely picture. Ooh. This is just a sketch. So if you look at the questions, it wants to know, where is your vertex? Where is your directrix? Now, we've already found the directrix. The directrix is at y equals 3/2. Where is your vertex? Where is this dot located?
Wouldn't it be when you just divide it by 2?
Mm-hmm.
So it'd be 3/4.
Sounds good to me. 3/4, comma, because it's a point.
0.
Zero's here, the black dot. We're on the blue dot. What line is this?
That's the pi. Oh, pi halves.
Yeah. Remember, these are polar points, not rectangular ones. So it's 3/4 pi halves. How do we draw y equals 3/2 on a polar graph? Yes, Jude, that's a good question. It's still just a line. So is x equals a number. It would still just be a line. Thanks for the question. That is correct. Did y'all see what Jude wrote? He just said, hey, is it a different way that we would draw a line on polar form? And the answer is no. You would just draw it like normal. Okay? Everybody okay with A? Okay, let's try B. B says R equals 6/3 minus 2 sine theta. So the first thing that I'm going to notice is that this is not in standard form. So I'm just going to give you a minute, and I want you to try to get it to look like this using algebra, okay? Trying to get it to look like that so that we can see what E is, so we can see what D is, so we can start our sketch, okay? So I'll give you a minute. All right, did we get it?
Yeah.
Hello?
I think so.
Yeah. Okay. What do you think you got?
I think I got 2/3 times 2 over 1 minus 2/3 sine theta.
I think maybe, except for the 2 part on the top. Let's check it out. So you divided by 3. So that should be the first thing. Everybody should divide by 3 because you want this leading one to be a 1. So if you divide that by 3, is that okay? So then if you do that, you would have R equals 6 divided by 3 is 2. And then you have 1 minus 2/3 sine theta. Is everybody okay with that? So then you know that your eccentricity is 2/3. So when you come over here, you have to split this. So then you have 2/3 for your E, but what is your D so that when you multiply them together, you get 2? Does that make sense? You don't add the E on top. You actually have to split whatever number this is because that's making up your E times D. So then what is D?
1/3.
Nope.
No.
2/3 times 1/3 is not 2. 2/3 times what gives you 2? Yep. Jude said it's 3, and it is. So 2/3 times 3 gives you 2. And this is your setup. Is that okay? So it's these two numbers multiplied together has to give you what already is up here. 2/3 times 3 is 2. Is that okay? And so now we know that E is 2/3. If E is 2/3, what kind of conic is this?
It is a hyperbola.
How did you figure that out?
Because the formula? Oh,
Go
wait. It's an eclipse?
How do you know that?
Because E is greater than 0 but less than 1?
Yep, exactly. That's exactly why. So since 2/3 is in between 0 and 1, this is an ellipse. But I wanted to prove a point. Do you see how much we're referring back to that front page? So that front page is very, very important to study, okay? So it's an ellipse because E is between 0 and 1, so I'm cool with that. And since you have 1 minus E sine theta in your denominator, we're going to go ahead and start sketching this. Do you agree that your here's your focus and your directrix is going to be somewhere down here, right? So your directrix is at y equals -3. Is everybody okay with that? Any questions? Now, the next thing it wants us to do is it wants us to find the center. It wants us to find vertices, the directrix, length of major axis, length of minor axis. So I'm going to go through this nice and slow. A lot of people make this mistake. They come over here and say, okay, well, that means the vertex is in between. That's only true for parabolas, right? It's only true for parabolas. It is not true for ellipses and hyperbolas. So be very careful, okay? However, what you can know, because it's set up this way, is that there is going to be a vertex on this line, and there's going to be another vertex on this line. So if you were sketching it, it's going to look something like this. I just don't know where those dots are. Maybe I should have made them a different color. There's your vertex 1. Here's your vertex 2. I just don't know where they are. I know they're going to be somewhere on these lines. So what I'm going to do is I'm going to come over here and I'm going to make a table. And when I make a table, I'm going to have r comma theta, the r comma theta table, okay? And do you agree that this angle that V1 is on, and here's V2, the angle that V1 is on is pi halves. The angle that V2 is on is 3 pi over 2. Do you agree with that?
Yes.
So then now we have these thetas, right? We just need r. Can't you substitute these thetas into here to figure out what r is going to be? So for the first one, you could do r equals 6 over 3 minus 2 sine of pi halves. Now, what is sine of pi halves? 1, right? That's 1. So then this is going to give me 6 over 3 minus 2, which just gives me 6. So I'm going to have 6 pi halves. This vertex is at 6 pi halves. The second vertex r equals 6 over 3 minus 2 sine of negative pi. Oh, negative 3 pi over 2. Sorry. I was going to put negative pi, which would have been the same thing. But 3 pi over 2. Okay. What is sine of 3 pi over 2? Negative 1. So you have negative 2 times negative 1. Wouldn't that just give you 3 plus 2? Which gives you 6/5. So 6/5, 3 pi over 2 is your other vertex. That's your V2. So we have our vertices, we have our directrix. Then it's going to ask me for my center. How are we going to find that? Where is your center located? Between what?
Between the two vertices.
Yeah, I agree. Between the two vertices. So then what point, I'm going to do a different color. Let's do orange. What point, pretend that's in the center, is between the two vertices? How are we going to figure that out? Well, does anybody know what the length of the major axis is?
Can't you just add 6 plus 6 over 5 divided by 2?
What is that?
3.6.
What is that as a fraction?
18 over 5.
Oh, super close.
Hmm.
Let's see. I agree.
I just added the 2, and the length of the major axis is 36 over 5.
I agree with that. So length of the major axis is 36 over 5. The distance from here to here is 6/5, right? Because that's 6/5, 3 pi over 2. And the distance from here to here is 6, since that's 6 pi halves. So if you add the 6 and the 6/5 together, you get the length of the major axis. So the length of the major axis is 36 over 5. And you got that by adding the 6 and the 6/5 together. Okay, so that's the length of the major axis. So then couldn't you divide that by 2? What is 36 over 5 divided by 2?
18 over 5.
Oh, okay, yes. I'm cool with 18 over 5. Now, 18 over 5 would be half the distance between the two, right? So where is that located? That's A. So then where is the center though? Because it's shifted. Does that make sense? It's not exactly in the middle because it's shifted up. So I agree that A is 18 over 5. Let me write that down.
So, quick question here.
Yeah.
What is it?
Yes, Jude, it's 12 over 5. Explain how you got that. Okay, maybe I can help. Okay, watch this. Maybe this will help. Maybe my picture's too messy. You got 18 over 5. Do you agree with that? That means the distance, look up here. I'm going to do a different color. That means the distance from here to here is 18 over 5. And the distance from here to here is 18 over 5. So if your center was at 0, makes sense? Then it would be 0, 0, 18 over 5 in each direction. But this is where your center is. That is not 18 over 5 above the pole. Does that make sense? So then what is
So
this?
couldn't you just do 6 plus 6 over 5 divided by 3 to find the mean?
Whatever you have to do, there's lots of ways to do it. But I need you to find the distance from here to here. So you could take the 18 over 5 and take the 6 over 5 away. Does that make sense? Because you know that this is 6/5. So for the blue, if the whole thing is 18 over 5 and you take the 6/5 away, you're left with that point right there, which is 12/5. So your center would be 12/5, comma, and then pi over 2 since it's above the pole. And that's your center. Dividing by 3 works for this problem, but I don't think it works for every problem. I don't know. I didn't divide by 3. I did 18/5 minus 6/5. Okay, so now we found the center. We found the length of the major axis. It wants the length of the minor axis. So how are we going to find that? What was the relationship between A, B, and C for ellipses? Does anybody remember? Going back, this is because of time, but going back, if you go back to ellipses, you know that A squared minus C squared equals B squared. Now, you came up with A. A was 18/5. So 18/5 squared. I'm cool with that, right? B, well, I mean C, what was C? We're looking for B. C was the distance from the center to the foci. So from the center to the foci.
Dr. Crucili.
Yeah?
The ellipse equation is A squared equals B squared plus C squared.
And if you move the C
which
squared
is the same thing.
Side,
I'm sorry.
It's okay, because you're looking for B squared, right? Because we're looking for B squared.
Yes.
So C is 12/5. I'm going to square that. And I have no idea what this is. I didn't do it. 18 squared, 324. Did I get that wrong? Is it 18 squared, 324? Yeah, okay. And then what is 324 minus, 324, I wrote 5, sorry. 324. Okay. And what is 324 minus 144?
180.
So then this gives me 180 over 25. That's B squared, but we have to take the square root of that. Anybody have a Casio? Does it come out pretty? I know the bottom's 5. The square root of 180. 37. No, that's not right.
It should be 36 over 5, and then we still got to square root that, right?
So 6 the square root of 5?
6 square root of 505.
Okay, so this is B. So B is equal to 6 the square root of 5 over 5. What is the length of the minor axis? How do you find the length of the minor axis?
I just
multiply it by 2.
Very good. We're going to multiply it by 2. So you get 12 the square root of 5 over 5. And that is the length of the minor axis. And we found everything. We found the center, vertices, directrix, length of major axis, length of minor axis.
I have a question for you.
Absolutely. Go ahead.
For eccentricity,
Eccentricity.
for an eclipse, eccentricity equals C over A. So you couldn't work it like that, where your C would just be 2 and your A is 3 now, since you found it's 2/3?
I don't think so.
Because the math isn't the same. You get the wrong answer. I was trying to work it out.
That's
But
a
in the
question. I
eclipse's
wonder if it's
rule,
only C over A in rectangular form.
okay, that's what I
polar.
was thinking. I was just,
That's a good question. I don't know. Let me go back and play with that. But my
that's where my first instinct went before
Yeah.
we
No,
started
I
doing
get
all
it.
this other stuff.
Yeah, no. That's a good. That's a good for me to try it. I would have thought of that too. And I'm trying to think if that would be the same thing in polar. C. What was our C? What was C? Our C was 12/5. Where's my calculator? Our C is 12/5. And then divide that by A, which is 18/5, right? And you get 2/3. It's still C over A.
Huh.
It just that happens that it's a very particular distance. Does that make sense? Like it's 18. Yeah, you still, because there's a lot of ways to make 2/3. So we just don't know how it's split. But you're right. Like, could you do it with just those values? Because you would get the same eccentricity, but it would be different distances. Does that make sense? Like, more than one jar can have the same volume. That doesn't mean the jar has to be the same dimension. So the sizes could be different, but it could hold the same amount. So I'm thinking that's what's happening here. Even though the ellipse is 2/3, the distances are different. Does that make sense? Because you could do this and it'd be 2/3, and I can make it the same size this way, and that's 2/3, but they're two different ways of drawing it. So I think you have to do it this way because it's looking for a very particular way of it being drawn.
That's fair.
Does that make sense?
I mean, polar and rectangular are very different. So
yeah. Okay. I know I'm out of time, and if you have to go, I totally understand. I would love to do C if some of y'all want to stick around, because C is too. So we could just get some additional practice. But if you have to go, I totally understand, and you can totally go. I wanted to say thank you. This is our last class, and I want to say thank you for working so hard. And I know that this has not been an ideal term. Just don't forget that your homework for chapters, what chapter are we in? 11? Yeah, is due Sunday. So your homework and your lab for chapter 11 are due Sunday. And then your final exam, the latest day that I'll take it is Monday. So that is the very last day that I will take it. And then I'll compute your grades the next couple of days after that, after everything's graded. If you happen to take your final exam early, let's say you're like, hey, I pretty much have all my homework done for 11. I only have to do 11/6. I'm going to go ahead and knock that out. And I'm going to take the final exam on Friday. Cool. If you take the final exam, though, that is your communication to me that you're done. Okay, so then that means I am able to compute grades. I'm going to try to compute grades as they come in so that I don't have a whole bunch of grading to do next week. So once you take your final exam and I notice that you've taken it, I'm going to compute your grade. So if you email me and say, oh, I wasn't ready for you to compute my grade yet, I still have some homework to do, the answer is going to be no. I'm not going to accept the homework. So do not take the final exam until you are completely done with everything else and you're ready for me to compute your grade. Does everybody understand? The final exam should be the final exam should be the very last thing that you do, which is why we call it a final.
makes sense.
Yeah, right? Makes sense. Anybody have any questions or concerns about that?
Can you just scroll up real quick while you're giving everybody the lowdown?
The speech?
Thank you.
Yeah, no problem. Is everybody okay with what's expected and what you're supposed to be doing over the next couple of days?
Yes,
We're
ma'am.
good? Okay, just making sure. Okay. Like I said, if you have to chop, you are more than welcome to go. I'm going to do part C, which is the very last problem, just because it's very similar to this, and I feel like getting the practice is good. Okay, where's my pen? Okay, so here we go. Part C says R equals 10 over 1 minus 4 sine theta. So the very first thing that I want you to do is I want you to get it into the form that I can work with. The first number is already a 1. Do y'all see that? So that's awesome. That's already a 1. So the bottom is going to stay 1 minus 4 sine theta. That 4 is your eccentricity. So I'm going to have a 4 here. This is your eccentricity. What is D?
Five halves.
I'm going to put 10/4 in here so that you can see it better in case it's in your notes. But when I write it over here, E is 4 and D is 5 halves. So then what kind of conic is this?
Hyperbola.
This is a hyperbola. And how do you know that?
The eccentricity is greater than 1.
Garrett, I missed you when you were absent. You're the only one who talked to me. No one wants to talk to me.
I have to. That's the only way I learn is through conversation. I can't
Yeah.
just listen and write a note.
You good? Is everybody okay? Because everybody's being hard. Jefferson, where you at? Your microphone works. You good?
Yes, ma'am.
Melissa, you good? Your microphone works. Leanna, I don't know about your microphone. Jude's my typer. Jude, you good? Okay, everybody's good? We okay? Okay, so everybody's good so far here. If you look at the denominator, we have 1 minus 4 sine theta. So if you go look at those pictures, those really pretty pictures, do you agree that your directrix is going to be a horizontal line down here? Do we agree with that? So that's going to be y equals negative 5 halves. Right? You have a pole, you have a focus at the pole. The distance between your pole and the directrix is 5 halves distance. So I went 5 halves down. Here's my directrix. Is everybody okay with that? Let's go one thing at a time. So here's your directrix. We're good with that because it asked us to find that. So we have that one now. Which means that you are going to have a vertice here. Do you agree with that? You're going to have a vertice here. So that's going to open this way. And then you just told me that I'm going to have a hyperbola, right? So you're going to have a vertice here. I know this is going to be weird. Just stay with me. You're going to have a vertice here. That's going to be the closest one to the pole, which means that you have a vertice here that we're going to talk about here in a second. We're going to talk about this special vertice in a second. Then I told you, once you figure that out, you're going to come over here and you're going to make an R and theta table. That means that our theta is going to be pi halves and 3 pi over 2, just like the last one was. Pi halves and 3 pi over 2. While you're writing that down, I'm just going to scroll really quick to the top. We had the directrix in the same kind of place. So we knew that we had a vertex here close to the pole, and then the other one was in the opposite direction. So if you notice the pink, it's very similar. If you have, this is a side note. This is a side note. I'm going to erase this side note here in a second because I don't want it to confuse you. This is not a part of the problem. If you had, let's say, an ellipse or something, and here's your coordinate plane, and here's your directrix. Here's your directrix. Here's the pole. Then you know that you have a vertex here and a vertex here. So then when you come and make your R theta table to find out where they are, your angles would be 0 and pi. Does that make sense?
Yes, it does.
I'm stopping. Because your directrix is here and your foci is in the middle, that means your vertex is in between. We don't know exactly where in between because it's only equidistant for parabolas, right? So we don't know how far in between it is, but we do
So
know.
every time we see cosine, we're going to use theta, 0, and pi, and every time we use sine, it's pi halves, 3 pi halves.
Mm-hmm. Yeah. Yep. Does that make sense? So this is a little side note that has nothing to do with this problem. I hate the fact that we chose ones where we're using sine on both of them. And so therefore you know that your directrix is horizontal and your vertices are going to be on these axes. Is that okay? So far so good?
Yeah,
Everybody
makes sense.
understand? Okay, cool. So now, now that we know where these angles are, I need you to substitute these angles into the original problem. I mean, you could do it here, but there's so much to type in. So I would do it here at the original problem to tell me what R is at these angles.
I get 10/3 and 2.
10 thirds and 2. When you put pi, negative 10/3?
Yeah, negative 10/3.
Yeah, my bad.
It's okay. I just want to make sure I wasn't wrong. I just looked at mine. Is it negative 10/3 and 2? Is everybody okay with how Garrett got that and Jefferson got that? Are we okay? Any questions there? Because I'm about to blow your mind. So is everybody okay so far with this? Anybody need me to do anything? You should. I'm not doing the work. I did it over here, but they did this part where they were doing the first and second. So they're substituting those values in and then simplifying, and that's how you got the negative 10/3 and the positive 2. Is everybody okay with that? Okay, watch this. This is the part that's going to blow your mind. Oh, so this point is not right here. Shoot. That point that I'm going to make a ghost of, which was over here, is not right there. It's over here. So that means that this is going to go this way. How do I know that
That turns it into a parabola.
But how did you know? How do I know that it's not where it's supposed to be?
Because a hyperbola is always supposed to mirror itself.
No, that's true. I agree. Everything that you're saying is beautiful. There's a special reason why.
Oh, because you restricted the domain with the directrix?
No. So when you did pi halves, here's the pole. Here's the pole 0, 0, right? Here's the pole. So you have 10/3 pi halves. Pi halves is this line. But since your R is negative 10/3, does anybody remember what you had to do when your radius was negative?
You have to go the opposite way, right?
Yes, you have to go the
180.
opposite way. So it's not up here. You have to 180 degree it. So that's why it's here, which makes sense, because how is the vertex going to be here if the parabola opens this way? Like, how is this supposed to open? Does it make sense? So it makes sense that this is the dot that had to move 180 degrees so that it could open outward. Okay? So this is 10 thirds pi halves, because you went pi halves, but it was a negative 10 thirds, so then you had to flop the other way. We practiced this when we did polar, graphed polar points. So far, this is our picture. Now, what sucks is, and you're going to make little notes, is that when you're trying to find the center and things like that, you need to keep this in mind that you move the point, okay? So you want to be careful. So we have the picture, we have our vertices. So these are your vertices. This is what you would type into WebAssign. If it says, what are your vertices? These are them. So we have our directrix, check. We have our vertices, check. Oh, okay, where's the center? Where's the center? So remember, the center is somewhere in here. So I'll give you a hint. The center is something, comma, 3 pi over 2. You're welcome. Because here's the origin. This is pi halves up here, but we didn't go pi halves. We went down. So it's 3 pi over 2. My question is how far down? What is the distance? I'll let you chew on that for a second.
I got.
That's what most of them look like.
Mm,
But yeah, so tomorrow I'm just gonna
negative
type for
16
us tomorrow
ninths.
to work on it, and I'll get
It wouldn't be negative, because if it's negative, then you'd have to flip it.
Oh yeah. 16
It should be-
ninths?
it should
No.
be on there. It should
What is
be like
16 ninths?
pieces, so I don't know.
Does that reduce? No, it doesn't.
No.
Nope, it's not 16 ninths.
Yeah, I don't know. I'm gonna send it to her in case she wants to join us, but I'm gonna set up that time for that for tomorrow.
What is the length of the transverse axis? Okay, so maybe this will help. You see it better. I'm going to show you this. You see it better before you flip the point. So I will let you think about this if we were in class for more time, but before you flip the point, you see it better. The distance from here to here was a 10 thirds distance, right? The distance from, what is the other distance?
2.
Oh, thank you. Yes, it was. The distance from here to here was 2. Ooh. Do we agree? So that's vertex to vertex. That's the length of your major axis, your transverse axis. So then if you're looking for the length of your transverse axis, wouldn't that be 10 thirds plus 2, which gives you 16 thirds. So that's 2a basically. But you need to divide that by 2 in order to just get a. So to get a, you would get 8 thirds. Do we agree with that? A is 8 thirds.
Yes.
Okay. So if this is 10 thirds, and that's 2, in between there, you have a value of 16 thirds. So in between here and here is 16 thirds. Half of that is 8 thirds, but you're going from here down, so it is 8 thirds. So I think the center is 8 thirds, 3 pi over 2. Let me look at the distance again. That's 2 From here to here is 10 thirds, 16 thirds. Half of 16 thirds is 8 thirds. That's this point. But that is going down. So from here to here is 8 thirds. Is it? Now I'm like questioning myself. Maybe I have too much blue. Let's look at it again. Do we not have to add the 2? I did. 10 thirds plus the 2 is 16 thirds. I added the 2 here to get the length from vertex to vertex. So from vertex here to here is 16 thirds. The center's in the center of that. So that's 8 thirds in between. So that means that from here to here is 8 thirds. But we don't, and this distance, oh, I see what you're saying, is the 2. So you actually have to add the 2 and the 8 thirds, and that gives you the center. You're right, I'm wrong. You're right, I got too fuzzied. So it's 8 thirds and the 2, which gives you what is that? 14 thirds?
14 thirds.
Seems so big, doesn't it? 14 thirds is more than the 10 thirds. Now I'm like questioning this problem. I don't know why. When I did it myself, I put 8 thirds down, but I'm wondering if vertex to vertex, looking at that distance. Everything else I feel confident about. Now I'm wondering about the center. I'm gonna have to try this on a homework problem and look at it. These darn pictures. Seriously.
Why would you have to add the 2 from the top
Because you're
vertex
trying
to the origin?
No, yeah, you're trying to find like graphing the center. So here's the center. We're trying to graph it, right? So I'm trying to find out where that is. It's in between the vertices, for sure.
Absolutely.
In between the vertices. Like that I know for sure. So this right here was a 10 thirds distance from the focus, right?
Yes.
So this is a 10 thirds distance from the big one that's furthest away. That's a 10 thirds distance. From the focus to the other vertex was 2.
Yes.
So it was 2
Okay.
down. I'm cool with that. So then if you were to go in between these, where would you be? Is what I'm saying. The problem is that if
Can you
you
hear me?
flipped
Can you hear
this 10 thirds down, it's still a 10 thirds distance. You just went in another direction,
Can you hear me now?
right?
Okay, fine.
So
Yes.
here's the vertex.
So it either way, you'd still be adding the same 2 numbers, 10 thirds plus 2, which would
Yeah.
be the 16 thirds. And you divide that in half to find the middle point, correct?
So it would still be 8 thirds. You wouldn't
Yeah.
add the 2.
You added the 2 3 times, which I don't
Yes,
think you
I
should
shouldn't do that. Okay, let's clean this up. I get what I'm doing now. I get the picture now. Oh shoot. Here we go. Okay, I get the picture. Last thing. Here we go. Stop. Okay. Here's the vertex. From here, from this vertex to this vertex is 16 thirds. That is the length of the transverse axis. I'm fine with that. You did the 10 thirds from the first vertex plus the 2, and you got the 16 thirds. Half of that would be 8 thirds. So do you agree with that? Halfway in between here is 8 thirds distance from here to here is 8 thirds. So then how far is that from the pole? It's still 8 thirds. If we had more time, I would do this again and do it tomorrow, but we don't have more time. Okay. I'm going to try to,
always be 8 thirds because your pole is 0 0.
0, 0. And so then it's an 8/3 distance. That's what I keep getting. But I don't know if my drawing is supporting what I'm saying.
I
You know what I
think
mean?
it is.
Okay. Well, then good. Because that's what it is. I keep getting 8/3. Okay. If I have an epiphany I'll try to make a video and I can send it to y'all. If I have an epiphany on how to make the picture better. I did the same thing with calculus. I was like, oh my God, I can make the picture so much better. But that's how you do it. Okay. All right. Well, that's it. Sorry. We did all of the vertices I'm cool with. The center the center I'm good with. I mean not the center. The directrix I'm good with. What we did.
I had a
all of that.
question
Sure.
about the vertices.
Okay.
Since the negative 10/3 pi thirds, or well,
Pi halves?
3 pi, yeah, pi halves. I wrote that wrong. Since that's below the directrix, do we include that in our answer?
Do we include what in your answer? The vertices?
Yes.
Yes, you do. So if
Okay.
when it asks you for vertices, you would still put both.
Okay. What is? I've always thought of the directrix as restricting the domain. Is that not what it is? I guess I need to go back and read.
You know what? I just thought of something. Watch this. Remember I told you sometimes it makes more sense before you flip it? So here was our point, and you were just asking me this question. Here was 2, 3 pi over 2. You agree with that?
Right.
Here's 2, 3
Yes,
pi over
ma'am.
2. Here it's technically 10/3 pi over 2. I agree that's not what we got. We got negative 10/3, which means we had to flip it. The distance between here and here is 16/3, right? The distance between the vertices is 16/3. If you half that, you'll get 8/3. So in
Right.
between here is 8/3. The distance between here and here is 8/3. The problem is that you have to flip them, right? Because this is where your vertex normally is. So then this is 8/3, not pi over 2, 3 pi over 2. I think it makes more sense if I do it like that before flipping.
Mm-hmm. Okay, I see what you did there.
I think that's better. Yeah. Do we have? Okay, so that makes more sense. Okay, thanks guys for sticking around. I know I was like way over. Sorry.
It's all good. Thank you.
You're welcome. I'll talk to
Yeah,
y'all later. Email me if y'all have any questions or concerns, okay?
Yes, ma'am.
Yes, ma'am.
Bye.
Good luck.
Later,
Bye.
everybody.
No, thank you, Leanna, for staying.